All right, guys, welcome back to my podcast. So we're about halfway done of chapter one. Okay, but the whole chapter one is just reviewing. Take a look right here. I'm sure you see this many times in Gen Chem 1 and 2, right? So electronegativity. But we're gonna talk about just a little bit of it in terms of how do we use it in this course specifically. Okay. All right. Let's see. So electronegativity is a relative ability of an atom to attract shared electrons. Okay, so pull electron to itself basically. And if you still remember, the highest electronegative atom in the periodic table is fluorine. And if you're the further away from the fluorine, the lower electronegativity. Okay, so the top electronegative atoms are right here. So, and if you can memorize these, it will help you. Instead of to look at the periodic table, this one can help you like just the top electronegative atom. Okay, so let's see what we got here. We have FOCl, that's the top three, N, Br, S, and all the way to hydrogen. So hydrogen is the least electronegative atom among non-metal, but still has higher electronegativity than metals. Okay, so we have FOCl, NBRS, and all the way to hydrogen, the lowest in among non-metal. All right, so we have a little bit mnemonic right here. So if you still remember like the reputation of organic chemistry, this is how students feel about organic chemistry. I'll take a look. So we got first, organic chemistry needs bourbon shot. Heck yeah! that's how we how I memorize it. Right, first time taking organic chemistry is so stressful. You need a bourbon shot. Okay, so that can help. That can help. So when you see like a bunch of different atoms, you know exactly who's the top electronegative atom, who the bottom electronegative atom. Use this trend. Okay. All right. Let's see how we use it. So I look at electronegativity as when you play tug of war. Like you pull the rope just like that, all right? So carbon and oxygen, you know that oxygen is like the second highest electronegative atom. The electrons right here between these two atoms, they're sharing, right? It's called valence bond. This electron gonna spend more time on oxygen, less time on the carbon, okay? And as a result, the electron cloud will kind of go toward the oxygen. So a lot more in oxygen and a little bit in carbon, right? And that makes oxygen a little negative and carbon a little positive, right? They don't share electron equally anymore. Oxygen get more electrons. So oxygen gonna be a little bit negative. When I say a little means partial, that's just a delta side, delta negative, right? So that's a partial negative, and carbon is a little bit positive. So we use partial positive sign. Okay, and that's what we call is polar band, polar bear. No, just kidding. Polar covalent bond, polar bond. All right, we're gonna use the cross arrow, look something like this to show the direction of polarity. We call dipole moment. Okay, a dipole moment, the direction of polarity. So in this case, the dipole moment goes toward oxygen to the right. All right. Now, in the case of the same atom, like carbon and carbon, the electron in between in the bond will be shared equally because they have the same strength, right? Same electronegativity. So as a result, the electron will share equally, and there's no polarity here, no dipole moment here. So we call this type of bond a non-polar covalent bond. All right. Now, one more. In the case that the electronegativity difference are large, really, really large, right? Sodium 0.9, fluorine 4, the highest and almost the lowest. The electrons right here they won't be shared. Fluorine will take away the two electrons in between these two atoms, right? As a result, you're gonna get sodium ion because sodium loses it entirely loses electron entirely, and fluorine gets the whole thing. Okay, that makes sodium a real positive charge, not partial, not a little. This is a real charge, and fluorine got full negative on it. Okay, and the attraction between the cation and anion is ionic bond. Look like that. All right. Now here's the cutoff. If you learn in general chemistry, you see a few type of cutoff in there. If less than 0.5, there's a non-polar covalent bond. Between 0.5 to 1.7, there's a polar covalent bond, and above 1.7 is ionic bond. All right. If we use this cutoff, let's take a look right here. So first one, look at the difference in electronegativity between oxygen and carbon. That's about 3.5 minus 2.5. That's 1. Okay, so this is a polar covalent bond. Carbon and carbon, same electronegativity, so no difference. So this is non-polar. All right, and the big difference right here. So 4 minus 0.9, that's 3.1. That's the ionic bond for sure. All right. Now, here's a little bit something that you need to know. This cutoff, you use it loosely. Don't use like, oh, this is cut off right here. This is ionic. This is polar. This is non-polar. You can't really use that. Sometimes it doesn't work, right? It doesn't work that way. Take a look at this bond right here. A bond between carbon and lithium. Okay. Now, if you look at the electronegativity different, 2.5 and 1. All right, subtract that, you will get 1.5. 1.5 suggests that the carbon and lithium bond is polar covalent bond. Hold on, is it really true? If we learn this in general chemistry and a bond between metal, lithium, and non-metal carbon, this is ionic bond. If you still remember that, right? Well, what I want to say is don't use this cutoff as like a real cutoff. You have to think about all bonds. They are in a spectrum. Okay, nothing is white and black. Everything is gray in between, right? So we can have super polar right here. We call ionic bond, and carbon lithium is somewhere between polar covalent bond and ionic bond, somewhere between right here. But you can't really use the cutoff right there. In reality, this is practically this carbon right here is really reactive. Right? We can this carbon can use the two lone pair, one from its carbon itself, the other one from lithium. Use this lone pair to form bond with someone else. Right? So in this case, carbon and lithium, we can treat carbon and lithium bond as an ionic bond. This is also acceptable. Okay. All right. Another example, you're gonna learn this in a lot more in alcohol chapter, the last chapter of this course. We have a reagent called Grignard reagent. This is not an English word. This is a person's name, right? Grignard reagent. This carbon and magnesium bond. If you look at the difference in electronegativity, 2.5, 1.2, it's only 1.3. Right, so whereas there's a polar covalent bond, this is not a covalent bond. Practically, carbon acts as an ionic bond. This guy totally got a negative charge on it. Really reactive. Right, can react with it even with the moisture in the air, the water. Okay, so use the. I would say don't really use this cutoff. If you see metal, non-metal, actually that's an ionic bond. Okay, you look at the bond as a spectrum. Don't use a cutoff like that. All right. Now, can you identify polar bonds and ionic bonds in the molecules? Okay, so we have sodium methoxide. This guy's the name of it. You will learn the name later. All right. Let's see. Now, can you see an ionic bond here between sodium and oxygen? Okay, so if you see metal, basically for this course only, if you see metal, non-metal, you can call that that's an ionic bond. You can treat them. It's acceptable to treat this bond as ionic bond. All right. So you can do a negative and positive there, so the ionic bond. Now polar bond. If you see the polar bond right here, we have one polar bond. Okay. Carbon and oxygen. So I'm gonna put partial negative on the oxygen and partial positive on the carbon. Look like that. That's how we identified it. Okay. CH bond also a little. This the difference in electronegativity of carbon and hydrogen is really small. Take a look there. You only 0.4. So we treat them as a non-polar. All right. So let's try this one. So identify a polar covalent bond, assign partial positive, partial negative, and an ionic bond using positive and negative on appropriate atoms. Okay. Start with the molecule on the left side. So start with that bond right there. So you know oxygen and carbon. Right. This is a polar covalent bond. So oxygen got partial negative, carbon get partial positive. Same thing with CO bond on the right side, right there. Same thing, carbon positive, oxygen partial negative. Okay. CO bond right here, same thing right there. Carbon partial positive, oxygen partial negative. Sodium and oxygen, on the other hand, that's a metal, non-metal. It's acceptable to treat this guy as an ionic bond, positive and negative, real charge in there, not partial. Okay. All right, go to the right side right here. start with the C double bond O, you can see that that's a polar bond, polar covalent bond. So oxygen get partial negative, carbon get partial positive. All right. Our carbon-carbon bond is non-polar. Carbon-magnesium bond right here. Now that's an ionic bond. So you can treat them as a positive on magnesium and negative on the carbon. Okay. Same thing with magnesium and bromine. You can treat them as an ionic bond as well. All right. Okay. All right. Let's go to the next video right here.